Hello everyone, my name is Marie Correctler and welcome to today's AIRAH Technology Talk webinar session. Apologies for the slight delay in getting started today. We just had a couple of technical difficulties, but we should all be under control now. So look, today's Tech Talk presentation is presented to you today by Testo, and it will feature a live demonstration and knowledge sharing that will explain the impact on superheat versus evaporator superheat. But just before we get started and get underway, if you've got any questions throughout the session, as always, pop them into the Q&A box and then we'll go through them at the end of the presentation, and hopefully we'll get through as many questions as possible within the time permitting. So I'd now like to introduce to you our presenter for today, who is Morty. And Morty is the owner of Freeze Point Refrigeration, who'll be actually conducting today's demonstration. So Morty, I might now pass things over to you and you can get us underway. Thanks, Morty.
Yeah, thanks a lot. I am Morty Mandalawy, and I'll be presenting on behalf of Testo. I've joined Refrigeration in 2005, working with my old man. So I'm second generation into this field, and find it really interesting as the years came by. And slowly growing my business, started learning a lot more. So I finished my courses, finished my certificate 3, and then went out further and did my engineering courses. And yeah, so today we'll be talking about superheats, evaporator superheat, because I get a lot of questions of where superheats should be measured, where the system superheat should be measured as well. It's very important that you have an idea where to get all these measurements correctly, because if you don't, the system will run really poorly. It'll end up costing the client more in running costs and potentially damaging the system. So I'm going to take you through the system now, and we'll talk through it. So well, we can show you the screen on this one here. So come around. System is on, so we'll try not to keep the door open for too long. So when you connect the gauges, especially electronically, you would want to get the system inside the freezer. Give it about 5 minutes before you start taking measurements, whether it's mechanical or electronic. So we have already done that. So it's just to shorten it. We don't have to wait around too much. So evaporator superheat right now, we've got 8.9K superheat. Now during taking measurements, we always want to get the bulb temperature. So at that end, 1 second. So bulb temperature, which is pretty much, this is it. And this is your evaporator superheat. So if we had a pipe of 7/8, which is in this evaporator, and we have the pressure, the bulb of the TX valve sitting on the side like so, or up high. So we're not going to get the liquid on the bottom of the evaporator, the liquid evaporating, leaving the liquid leaving the evaporator. Very important is actually to have insulation around it, so to stop the airflow coming through on the bulb and giving it misreading. Now, generally on a larger piping, you'd want to get it on the bottom around 4 o'clock. Slightly smaller pipe diameter, it doesn't really matter where you put it because it's almost R1. Now, in some of the cases, and Husband cases, for example, they've got a really long heat exchanger where liquid and suction are touching each other, exchanging heat. Therefore, you can evaporate the liquid that's leaving the evaporator if there is misfailing of a TX valve or flooding, or the bulb got unattached. That will exchange and will have a potentially liquid flood back. They do that reason is to avoid liquid hemorrhage, liquid flood back. In the other tips of it is that you can get better efficiency out of the evaporator, and that helps the system efficiency increase by between 5 to 7% thereabouts. It's not always accurate depending on your conditions outside. If your conditions are 40 degrees or 42 degrees in summer, you're obviously not going to get that efficiency. If it's around 25 or lower, then you are going to get that. So what a lot of people do also, they get confused between evaporator superheat and system superheat. If your pipe run is really short, you can almost get accurate superheats of the evaporator, but not always. If you have a suction line accumulator on your system and you take the measurements before the suction line, that is closer to the evaporator superheat, not system superheat. The system superheat is taken always outside where the unit is, not where the evaporator. Evaporator superheat, and what a lot of people are realizing, they actually contact me and say, I've got a superheat of, for example, 15K at the evaporator. It's almost near impossible to achieve that. So when I speak to them and say to them, where are you getting the actual measurements from? And they say to me, I've taken the measurements off the cabinet temperature and my gauge. And I said, well, your bulb temperature is not the same as a room temperature. Your bulb temperature is basically needs to be 1 to 2 degrees colder than your cabinet. Therefore, this is why you need to get the instruments connected correctly and get the evaporator superheat and ignore what the case is. Why I mentioned earlier that your bulb needs to be insulated, because if you start up your cabinet at 20 degrees and your SSD, let's say on this low temp application is -15, your bulb temperature should be around the -10, -9, thereabouts, because you've got an electronic valve on this case, which always try to basically match the superheat that you set it to. Well, it will try at its best. Because you've got 20 degree return air temperature, that will make the refrigerant boil off really fast, and it will cause a massive gap of superheat. Eventually, when the temperature of the room comes down, you'll start to see the superheat will start to narrow down slowly until it matches the set point that you've actually left it at last. Best time to take measurements of the superheat when the case is at temperature, not when it's 10 degrees or -5. You just got to give it enough time to actually the temperature to come down and adjust it. In mechanical valves, it's always better to have the mechanical selection of the orifice 25% larger what the evaporator capacity output is. And obviously that's always selected by engineers at your wholesaler, or whoever the engineer that you deal with should know that by now. If your evaporator is starved and you connect your superheat, your measuring device, and your superheat are really a big gap, and you can't tell what's causing it. So there's two things that can cause that: is incorrect orifice, or your bulb has been broken and it's completely shut or partially shut of the orifice. The other thing is if you have welded throughout the system and you've got all that carbon stuff going back to the strainer, and it'll block up the strainer, so you've got partially feeding evaporator, not completely. So the evaporator superheat, we've covered all that basically, and we're going to go outside where the system is. This system here has a VSD, so if we try to shut down half of the evaporator, the suction line will remain, because the compressor will completely back off, because we have a common suction line at both evaporators. So when you have a common suction line, doesn't matter where you put your gauge, as long as your bulb temperature, which is your clamp, so to say, for the temperature, is at your evaporator that you're using. So if I clamp out at this side, my evaporator, and I put my pressure gauge there, it'll equal to 1. It doesn't matter. If I get that and the clamp and then go somewhere else, I'll get the evaporator side, the evaporator superheat on the other end. But however, you might have a slight pressure drop, so try to avoid that. So every time you take an evaporator pressure, always be at the evaporator outlet and evaporator, the evaporator superheat pressure, not anywhere else. So we're going to go outside and have a look at the system, how it's actually running. Excuse the noise in the background, they've actually got building next door. So we've got the system connected here. Once again, if this sits in the sun for a long time, whether you've got mechanical gauge, electronic gauge, always give it about 5 to 10 minutes before you start reading, because sometimes it drops 5 of a bar, 0.2 of a bar, which is about 200 kPa. I work in a lot in bars, just not used to kPa. They are the same thing, just one decimal point between it. I'll explain this. This shows here 19K, even though the evaporator was actually at 8K earlier, as I mentioned it. Now, because of the liquid line it's touching the suction, you're getting a big delta T plus just on that evaporator, the system will actually start to pick up a lot of superheat from there. So you got to be careful of how much superheat are coming back to the compressor, because most of the compressors have got a designed allocated superheat. So design condition on this compressor is 20K. If we pass 20K, there are two things that you're going to be possibly damaging. You're cooking the oil on the compressor, which will go very black very soon. Two, you'll be damaging valve plates because due to excessive heat on the discharge. Now, generally the discharge temperatures on a compressor like that, you got to always allow it below 90 degrees, preferably around the 70 mark. If it's colder, no big deal, but as long as it's not colder than your ambient temperature, then you'll know you've definitely got an issue with the system itself. Now, in this system here, we have a liquid injection slightly to cool it actually down. You can see it there. So if I allow like that, and then get a temperature of the discharge, it actually well and truly hits over 100. Now this capillary here is just slide a bit of injection into the suction from the liquid line, obviously after the filter. That will actually go into the suction line accumulator, and that will help the system superheat to stay nice and cool. Now, not all cases that you'll need a liquid injection into the compressor. If your system superheat in the design condition, you no longer need a liquid line injection. Now, system superheat is very important to take it. You got to take it at the entry of the liquid, the suction line into the compressor. Now, a lot of people, what they'll do, they'll grab this sensor here and go, for example, about a meter back here, that's my suction right there. And if you've got liquid coming back through into the accumulator, you'll definitely get a completely different reading, which is almost between 5 to 7K. Now, that 5 to 7K would throw the system completely off if you are sitting on the limits of the case itself. So what I normally like to do, always get it right at the endless. You got the measurements? All right, we're going to go inside again. You're going to go have a look at the evaporator superheat. Since it's been running after defrost for about 10 minutes or so, we did have it at defrost earlier today. It's just to get maximum heat load into the evaporator during startup. Now the system has been stable. I'm looking at it right now. It's actually giving me 4.7K superheat. My SSD is minus 22. My exit temperature is at minus 17. Room temperature, it's 16. So this shows you you got 1 degree difference. Your bulk temperature is minus 17, which is 1 degree colder than cabinet, meaning the system is actually doing work. It's pulling heat load out. If the bulk temperature is actually warmer than the case, that means your system is starved. The other week, I had actually a call from someone who had a bit of an issue and couldn't get a stable superheat on the evaporator. And the first question I asked him, where have you got the actual bowl strapped to? And he said, yeah, to the suction. And he had one of those low profile evapes, and the pipes literally coming up and then go straight up. He had the bowl on the vertical side. Normally, you don't get really good reading from there because the liquid doesn't tend to like to flow upwards, likes to boil on the bottom. So as soon as you actually remove the superheat bulb of the TX, placed it on the bottom, he had completely different reading. As soon as he insulated again, he goes, the superheat was actually a lot better reading, a lot more stable. That's it. So what you can see, the first one there, guys, ignore the liquid temperature there because we haven't got the gauge actually connected on the evaporator side. You have a look at the first one there. Suction line temperature minus 17.5, and then you've got evaporation temperature of minus 23. There's your 5.5K superheat. We've got because this is an electronic valve, it will fluctuate up and down, and it will give you a very accurate reading all the time. I see. From what you can see, so during startup, if the case is at 20 degrees, that superheat will be completely off. Because the case is already at temperature, we will always you stop that saying stuff a little bit. Yeah, okay. Yeah, no, we're not really paying attention to the liquid temperature. So we've got 5.8K. This is most effective superheat that we get most of the time between 5 and 7. Some guys actually like to run it between 4 and 6. I myself like to run it about 4K to 5K maximum, especially on those cases because we've got such a large superheat exchanger on the liquid line there on the bottom. I'm not sure if a lot of guys actually use a lot of Hussmann and see those liquid line on the actual suction. So show you where we've got this massive superheat again. So that's what I was talking about. So you've got the liquid line right there, you've got your suction, and it's soldered all the way through, and that's about good 3.5 meters of heat exchange where it actually it makes a huge difference. So if my temperature leaving the evaporator at minus 17, minus 18, by the time it gets out of the other side, it's actually 0 degrees or even sometimes 5, it really depending on the liquid temperature that it's actually feeding in. It's all controlled by the liquid temperature at this stage. So what have we got here? So we've got 5.6K. So this case here has been running for, I think, about 12 months. We've never had an issue. Initially, it started the actual, when I started the case, the first thing I paid attention is system superheat, not evaporator superheat, because I knew that it had a large heat exchanger on the case itself. That was my biggest concern, especially on those can compressors, not the semi-hermetics. Semi-hermetic tend to handle a lot more superheat. Yet then again, they are completely two different design, two different compressors, and two different, wouldn't say application, but I would say design conditions for those compressors. When I connected my gauge outside, first thing I paid attention, as soon as I saw my system superheat was beyond the envelope of the design condition, it was about 23, 24 thereabouts, and it started climbing, and I knew I was in trouble there. So first thing I said, I'm going to check the discharge temperature. As soon as I checked the discharge temperature, it was 112 degrees. At that point, I knew I had to back it off completely. So quickly, I went to my wholesaler, grabbed the capillary, sized it up, had that liquid injection, and lowered my superheat at the compressor inlet. Now, if you have tried to adjust the superheat in the case and you couldn't reach it, then you know you've got an issue. Again, if there was no heat exchanger and then you've got a large superheat going back to the compressor, 1, it might be undersized piping, 2, uninsulated pipe work, which is on a brand new case, it's almost near impossible if you got bad insulation. If the case was 20 years old and then you pick up 10K of superheat additional, that is normal. If you pick up anything more than that, then again, I would be checking again the evaporator superheat and the system superheat. So you can see on the screen there the evaporator superheat fluctuating as low as, completely opening. I think it's got a 4K, 3K. So even though it hits, at one point it actually hit at 1K, but if you go and have a look on the system superheat, you actually won't get that that low. So there will be absolute no liquid flood back. So you can see the superheat is actually playing around 4K. And we don't have an outside again, and we'll take a look at this superheat. We'll leave this connected so that way we can actually see the difference. When you adjust evaporator superheat, do not adjust it when the cabinet is at 20 degrees or 10 degrees. If you're doing in medium temperatures, which is, let's say, 0 to 5 degrees, I would actually start adjusting my superheat with my valve, if it's mechanical valve, clockwise or anti-clockwise. If it's starving, you obviously got to go anti-clockwise to feed more refrigerant into the evaporator, and vice versa the other way. So if you adjust your superheat at 20 degrees and you're doing a medium temp, you are not going to get that superheat when the case is a bit lower. Once it gets below about good, so once it gets at that temperature where the on temperature, which is if your set point is at 0 and your termination at 0, and then back on at 2 degrees or 3 degrees, depending on your differential set point there, then I would adjust around the 5 degree mark. So when the case is at 5 degrees, adjust your superheat then and there, because that is when if the evaporator effective temperatures are applied to the case. So if you adjust it below that point, you're still going to get it perfect, but when it comes on, it'll probably starve or it'll flood. What happens if you don't insulate the actual the bulb at the exit? If your case is at 20 degrees and you've got air hitting the bulb, what will happen? The actual diameter, as I mentioned earlier, the actual diameter of the bulb will be affected by the room temperature, not by the pipe temperature. Therefore, it will actually flood. If you have it insulated, therefore, it's not affected by the room temperature. So the TX valve only sees and only feels the exit temperature of the actual coil. I'll just wait for the system to actually turn on and I'll give you some feedback on the temperatures. What I'll do, I'll actually switch off the VSD so it doesn't back off. It'll just be a fixed speed, like it's just a standard system for most the guys out there. And I'll just disconnect the liquid injection. So what I did there, I've just disconnected the liquid injection now. Just, there you go, just kicked in. So it's just going to come on at 50. So this is a fixed speed right now. It's no longer in a VSD, so it's not going to go up and down. I'm not sure if you can read that. So system superheat 30K right now. It's slightly dropping. So we've got no liquid injection. We're purely relying now on the evaporator superheat coming back to the compressor just to see how much difference it makes and how the system is affected by the evaporator superheat. Now, a lot of people will agree and say, yeah, the higher superheat at the compressor, the least amount of liquid coming back to the compressor. But having too much superheat, it actually does more damage than actually than any benefit from it. So right now, it's just stuck at 26K superheat, and it's just sitting there. So as the system warms up, again, it will pick up more superheat because, like I said, the liquid line is affecting the suction of the total system superheat. Okay. All right, we're not going to talk about the superheat anymore. We're going to move on to the next Mama, can you plug this up and then get it back from what do you call it? So we spoke about the evaporator superheat. Hopefully this makes it very clear for you guys. And the system superheat, what's the difference between the two? That if you've got a big pipe run, we try to avoid doing that. Now we're going to talk about vacuum. Vacuum is one of the most important thing in the whole entire install that when you do. It is that important. Actually, it affects your system running, your system conditions, your superheats, your subcooling, your whole entire thing. If you have non-condensable in your system, you are going to run a hot system. You're going to have some moisture in the system. You are going to affect the system again. Blockages, because if you compress air, turn into liquid inside the system, and it will eventually end up at your TX valve, and this is where it actually ices up. Now, a lot of guys will actually use a standard hose, which you get with your gauges, like these. This is a 3/8, and you've got a 1/4-inch gauge as well. And these can actually do the vacuum. I'm going to switch this off. These actually, they will do the job, but they are not a true vac hoses. A true vac hose is actually something looks like that. These are vacuum hoses. Now these are 3/8. Try to connect them directly into your system when you do. Yep. Try to connect directly into your system. Now, if your system was running in vac for a bit of a time and it sucked in moisture and there is nothing you can do, the best thing that you do, you got to evacuate this, reclaim the whole entire system, evacuate it. If you see murky oil or contaminated oil by moisture, and you can see the actual moisture in the oil, which is, it turns into like sort of milkish color, that means get rid of that oil. Do not put the fresh oil unless you vac your system below 1,000 micron. Try to hit even 800, 600. It's going to be really difficult, especially if the system was running previously. Now, while you're doing that, just remember, nitrogen is your best friend at this point. You do need nitrogen put in the system. Imagine if you've got a wet table, and the best way to dry it, you don't get a sponge that has got water in it, because as soon as you wipe it, it's literally the moisture's going to stay there. Nitrogen is almost equivalent to a dry, brand new sponge. So as soon as you put it over it, it all goes. So when you back it completely down, and then you see the micron is at 5,000 or 4,000, and then you see the graph. If you've got a new instrument that has graph, you'll see it spiking up and down, that's your moisture boiling off in the system, trying to exit the system, because backing will you'll start to separate the molecules between oxygen and hydrogen. So once you separate those two, they'll start to evaporate, and you'll see little spikes. And those spikes actually will be driven down, not upwards. If you turn off the vac and it sits there and it keeps coming up in micron, that means you have slight moisture still in the system. You dump a bit of nitrogen in it, bring it up to atmospheric pressure, back it out again. Once it's completely vacued out below 800 micron, this is when you should install the oil in your compressor back in again. Then you know it's 100% you've got good oil, and you start fresh again. Now, talking about steel compressors and system, how it should really go. We covered the vacuum. And by the way, guys, anyone's got questions, email Maria there, and she'll bundle up all the questions and email it to me, and I'll have a read through it, because there's a lot of guys going to have similar questions, so we'll have an answer for multiple questions that's going to answer everything. Now, we've spoken about the vac, we spoke about the superheats. Hopefully, I didn't complicate things too much. Hopefully, it makes sense to a lot of you guys. The system, if you're going to come to a system and you've got no tools and you're about to check and you're like, okay, well, I'm just around the corner. I felt like popping in. This client had a called you and you're in the area, you're having dinner or out with your friends or a weekend. Swing past, you don't have any tools. Your best tools are your hands, your senses, your hearing, what you can see. First thing is first, no oil around the system at all. That will tell you if it's got leak in it or not. 2, your hands are close to a thermometer, I would say. If it burns, it's no good. If it's too cold in your hand, get stuck to it, it's no good either. That means you've got a lot of flood back. Compressor should feel around the 30 to 40 degrees at the bottom of it. If it feels any colder than that, you do have a flood back. Compressor on top, generally, I'm talking about compressor in can. I'm not talking about a semi-hermetic. Semi-hermetic, do not touch the head. They are slightly warmer on the head. The can compressor on the bottom, where the oil migrates, you don't want it too cold or colder than your suction or sweating like your suction, because that is a sign of flood back. So you might need to go get your van and then double check everything. The liquid line should always be warm, warmer than ambient temperature. If it's cold, you've got non-condensable in your system. If you've got a filter dryer, if one side of it is hot or warmish and the other side is actually cold, your filter dryer is blocked and it's not feeding the system completely. What else are we able to cover up here? Your sound of your compressor should always remain the same. I'll just show the message. Your compressor sound should always sound the same. If you hear a knock, hissing, especially when it's off, if you hear a hissing sound, say bye-bye to your compressor or your valve plate. Your valve plates are gone. If the compressor runs normal temperatures and when it turns off, the temperature aggressively increases by double or more, then again, what happens in your suction, what happens in your discharge there, it's seeping through to the suction and heating up the compressor. So I just hope I covered everything up. If you guys have any questions, do not hesitate to ask Maria, and I'm more than happy to help you guys out. My name is Morty from Freespine Refrigeration. I hope you guys enjoyed what I've explained to you guys today, and I hope it actually made all sense to you guys. So if you guys have any questions again, more than welcome to throw it at me.
Terrific. Thanks so much, Morty. Look, we actually do have a question that has come through, Morty, so I might read that one out to you.
Yeah.
We have a question here from Christopher who's asking, just wonder what is the standard superheat range?
It all depending. It's actually a good question. A lot of people ask me similar question like this. It all depending on the application in the background that's sitting there. So if you've got a fruit and veg that requires high humidity, you will need to run it at lower KTD to keep the. I think it's echoing. Might need to turn that down. you need to keep the humidity in the room. So lower TD helps the system, the room superheat, the room ambient temperature low, and also at the same time keeping relative humidity in the room. If you have a bottle shop, which is relative humidity, it isn't a big deal, then between 5, the lowest I would ever go, to 7K. 7K is actually ideal for bottle shops. Now, the superheats, the highest superheat that you have will actually increase the performance of the evaporator. The lower, the least amount of capacity you'll get out of the evaporator. Does that answer?
Yeah, sure. Yep. And Christopher's also asking, just on that, Morty, does that apply in all refrigerant?
Any refrigerant or refrigerant superheat is equal to 1. So whether it's 410A air conditioning, or you have a freezer low temp on 404 or 507, 134A low back pressure, superheats must be applied all equally, irrelevant what the refrigerant is.
Does that apply in all type of compressor?
All type of compressors, yes. Now, can compressors do? They can't handle as much as superheats as much as a semi-hermetic compressors. Semi-hermetics tend to actually handle a lot more. They are tougher built, so to say. Air conditioning, most of the air conditioning nowadays are liquid injected. They are not a standard liquid injection like what we have here. So they are temperature monitored. They are pressure monitored. So air conditioning, again, it's a whole different field, but the superheats remain the same.
Another question here for you as well, Morty, that's just come through is what is the acceptable range for the superheat?
I wouldn't go lower than 4, especially at the compressor. You wouldn't want to, at the evaporator, wouldn't go any lower than 4 because you'll lose a lot of capacity out of the evap. And I wouldn't go over 8K. 8K seem to dry out a lot and ice causes a lot of ice up. Now, lower SST, higher superheat, it causes very bad oil flow. High SST, low KTD causes liquid floodback. So try to always stay between 4 minimum, bare minimum, 8 maximum. At the compressor, however, try to keep it above 10K superheat, which is very ideal. Do not go past 16 or 18K. When you hit around those temperatures, then you need to have a look at a slight different. Basically, you need to adjust your evaporator superheat. Your compressor superheat, which is your unit superheat, is literally controlled by the evaporator. I would just like to say to a lot of people, instruments, devices, gauges, tools are the best thing you can actually have in your van. The more instruments that you have in your van, the better mechanic you will become. If you are a little bit have, for example, if you were trying to get superheats and you don't have the right instruments, you're not going to, you cannot just guess and say, oh, it's about this cold, or I think it'll be okay. Try to get the right instruments for the right application. So I've got most of my gear from Testo's just because they really helpful with technical support if I've got any questions, warranty, service, whatever. But it's very important to have multiple tools, multiple instruments, always back up. They do help you and they do teach you a lot. It's not, you can't just learn everything of myself or just one side. It's going to be an experience over many sides.
Thanks, Morty. And just another question here for you as well. The high pressure is reading lower than the low pressure side on the reading that you had earlier up on the screen. Is that because we don't have reading on the liquid line temp?
That's correct. We didn't have, at this evaporator, we didn't have a port to actually connect to. Not that I didn't see any that I can connect to. I would have connected it if I seen a port, but as the liquid side, it's always going to remain the same, whether outside the evaporator, inside the evaporator, or at the system. It'll all equal to 1. Unless you've got a bad design pipe work, you will have a pressure drop. But in this system, we don't have any pressure drop because of the design condition that we've applied to.
But I'd just like to thank everyone who registered and attended for today's session. And thank you for bearing with us with the technical difficulties that we had earlier on, but we got there, so thank you. And I just want to thank as well Testo and, of course, Morty as well and the whole team for today's presentation. It was great, and we look forward to having the recording up on the AIRAH website. Other than that, we do have other upcoming webinar sessions and technology talks up on the AIRAH website, so please feel free to check those out. I will send an email in about a couple of weeks' time with access to the link for the recording. But in that, we do have a survey. So if you can please spare a couple of minutes to help improve AIRAH's webinars, we'd love to hear your feedback on our webinars that we host every 2 or 3 weeks. So that'll be great if you can spare a couple of minutes for us on that as well. So thank you all again. Thank you, Morty. Thank you to the team at Testo as well. And I look forward to everyone joining me at our next AIRAH webinar shortly.
Thank you, Maria. Thanks for having us.
Thank you. Bye-bye.